Good evening, everyone. We are back with another live video with our free math help tonight. I hope everyone had a great Thanksgiving break. I did as well. If you would like for me to do a math question for you, you can text me at 407-801-9255. I'll be more than willing to help you. So let's get started. Earlier this week, well, not earlier, well, this past weekend, someone texted me a math question, and I wanted to do that one first for them, even though I've already done it for them because they had to take a test, but I'll do it on the live as well. So for this question here, it says, a car travels a total distance of 200 miles at a rate of 55 miles per hour. The car uses 22 miles per gallon of gas. Determine the gallons of gas consumed by the car if it travels a total of 5 hours. So for this type of question here, it's a couple of things you have to do before you even get to the final answer. But let's get started. So the information that we are given is that we have a car that is traveling a distance of 500 miles. Okay. We also know that they are traveling at a rate of 55 miles per hour. Okay. So what we need to find out first is how much time did it take that car to travel 55 miles per hour when it was going 200 miles? So we're working with the basic definition or formula, and I'll put it up top. Distance equals rate times time. So in order to find the time, it is going to be the distance over the rate, or in this case, it'll be 200 miles over 55 miles per hour. So this time comes to be like about 3.63 hours. Okay, so that's how long it took the car to travel 500 miles at a rate of 55 miles per hour. Now we need to figure out how much gas was used. How much gas was used when they traveled 500 miles? Not 500 miles. Ooh, this is supposed to be 200. Hold on. I'm getting ahead of myself. Let's get this right. This is supposed to be 200 miles. My bad. Okay, so 200 miles. And I keep saying 500. I don't even know where I got that number from. So 200 miles. So when they traveled 200 miles at 55 miles per hour, how much gas was used? So in order to figure that out, we need to use the information here. They used 22 miles per gallon of gas. So in order to do that, we'll let G represent the gallons. So let's put gallons, and then we'll put G. So you had to go 200 miles, and you used 22 miles per gallon. Okay, this came out to be about 9.09 gallons. That's how much was used. So at this point, we really have like a gauge or a proportion that we can use to basically find out how much we could use, how much gallons we would need for 5 hours of travel. So our proportion would be 3.63 hours. In 3.63 hours, we use 9.09 gallons of gas, okay? We want to set that equal to 5 hours. And then we don't know how many gallons of gas that's going to be. But the good thing is that we can set up a proportion to figure out the unknown value. So when you cross multiply, you have 3.63x is equal to 5 times 9.09. And so let's keep going. That's going to get you 45.45. Divide both sides by 3.63. And so the number of gallons of gas you use for 5 hours of travel would be about 12.52 gallons of gas. And there you have it. Let's go to another question. Now this question here is an 8th grade standard or pre-algebra standard that students would see on the upcoming FSA if we still have it. So, and FSA is the Florida State assessment for, our state. So I'm in Florida. I know people are everywhere, but I'm in Florida, and this is an 8th grade standard. So it says triangle ABC and its transformation DEF are shown. It says what transformation of triangle ABC produce triangle DEF. So what you have to notice is that, okay, what's going on? So we know that A and D are the same. And then we know that C and F appear to be the same. And we know that B and E appear to be the same, like they're in the same location. But it looks like it's reversed. So it looks like it has been just like flipped over a line. So which transformation goes with that? So let's look at what we have. So a vertical translation means that you had to slide the original figure from one location to the next, but it still should be facing the same way. So it's not vertical translation. Then it's a dilation. A dilation means that a picture got bigger or smaller, and that's not what happened here. And then the next one is a rotation about point A. We did not rotate it at all, but we did reflect it across the horizontal line, and so that would be your answer. Let's go to the next question. My phone is ringing. Again, if you need some help or if you want me to do a problem for you, you can text me at 407-801-9255. But until then, I'll just do some math problems. So here's another problem. It says triangle ABC is translated 5 units to the right to create triangle A prime, B prime, C prime. So when you're working with a translation, and that's, it's a translation because they tell you that, and you're moving it 5 units to the right. So all you're doing is basically counting, taking each point and moving it to the right 5 units. No big deal here. So let's count. For the A, you go 1, 2, 3, 4, 5. So this would be A prime. And then for B, you go 1, 2, 3, 4, 5. This would be B prime. And C, you go 1, 2, 3, 4, 5. And this is C prime. And then you're done. You connect your pictures, connect your dots, and there you have a translated picture. No big deal there. Let's do another question. For here's another transformation problem. It says quadrilateral ABCD is rotated 90 degrees clockwise about the origin to create quadrilateral A prime, B prime, C prime, D prime. Now, this is a rotation and it's 90 degrees clockwise about the origin. Okay, so when you're talking about 90 degrees, well, first off, when you talk about clockwise, you're moving this way, like to the right. Okay? With 90 degrees, there is a certain rule that you have to know when you're trying to move it. So the rule is you take your original ordered pair, and we'll represent original ordered pair with X and Y, and then you're going to rewrite it as Y and then negative X. So you got to switch the numbers around, and then with the X, you're going to change the sign, and that's exactly what this means. So this is the rule for rotating 90 degrees clockwise. So before we get started, we need to get all the ordered pairs. So we have A, the original ordered pair is at -3 and 2, and B is at, what is that, 5 and 4, and C is at 2 and -5, and D is at -5, -2. Okay, so now at this point you want to determine what's going to be your prime values. So we have A prime, and if we're following the same rule, the Y value is 2, so I'm going to put that first, and then the X value is -3, but I need to change the sign, so it's going to be +3. And so the next one is B prime, and the Y value is 4, and the X value is 5. I'm going to change it to -5. The next one is C prime. The Y value is -5, and the X value is 2, so I'll make it -2. And then lastly is D prime. The Y value is -2, and the X value is -5, but I'm going to change it to +5. Okay, so let me pick a different color. Well, I can use red. Okay, so let's go ahead and plot these points. So A prime is going to be at 2 and 3, so I'll put a dot here and label it A prime. B prime is going to be at 4 and -5, and that is here. C prime is at -5 and -2, which is the original D. That's C prime. And then D prime is at -2 and 5. So now when you connect your dots, you have the same picture, but rotated. And there you have it. Rotated 90 degrees clockwise about the origin. Okay, let's go to another question. So this question here, it says, what is the measure of angle A in degrees in the figure shown? So, as a geometry teacher, I do have a problem with this question, even though I guess I just have a problem. If you notice right here, these angles are marked the same, but they're not the same. We teach our students that based on the markings, if they're marked the same, then they're congruent. But that's not the case in this question. So, whatever. That's just my personal thing I don't like about this question. But anyway, I'll do the problem anyway. So, it says here, what's the measure of angle A? So, angle A is here. What I know, I can solve this problem two different ways. I can notice right here, this is a straight angle. So I'm going to call this is a straight angle. So straight angles equal 180 degrees. So I can take this angle A plus the 167.3 and set it equal to 180. Okay, so I can solve the problem like that. Subtract 167.3 from both sides of the equation and get a zero pair here. So angle A is, let's do this math. So that's a 9, 7 is going to be 12.7 degrees. Okay, I could do that. Or with my geometry rules, I do know that the 167.3 is a remote exterior angle. Okay, so I know that these two angles here, angle that's labeled 126.4 and angle B together equal 167.3. So I could do that. And I should get the same answer. Well, I will get the same answer. So I know it's called remote exterior angle. And I know that 167.3 is a remote exterior angle. So I can say 126.4 plus angle B is equal to 167.3. And I can subtract 126.4 from both sides. This will be a little bit longer as far as work wise, but it's just another way you could do the problem. So this is going to be, what is that, 9, 0, and 4. So angle B would be 40.9, okay? So what you know that all three angles together, angle A plus angle B plus the 126.4 is equal to 180 degrees. That's the triangle angle sum theorem, which I know they don't really teach that actual theorem in 8th grade, but that's just something I'm just going to add on. So I can subtract 126.4 from both sides. And of course, this is the longer way to do the problem. Again, angle, and I know that B is 40.9. So 40.9. And I should have added them together. Let's do that right. Let me do that different. So that's what I would do. Hold on. Okay. So we know that angle A plus 40.9 plus 126.4 is equal to 180 degrees. So when I add these two together, let's do it to the side. 126.4 plus 40.9, 13, 7, 6. So you get 167.3 just like we got before. So angle A plus 167.3 is equal to 180. And then you subtract 167.3 from both sides. Again, angle A is equal to, and we already did this math, 12.7. So this is just two different ways to do the problem. The first way is to know that it's a straight angle. Okay, that was method 1. So this is kind of like the first way you could do the problem. And then down here would be the second way you could do the problem. Okay. Let's go to another question. So, dealing with angles again, it says, what is the measure of angle X in degrees in the figure shown? So, this is when you have to recognize what you're looking at. So I think my favorite part about looking at stuff like this, and when I see vertical angles, I automatically know that vertical angles are congruent. So I see right here, I got vertical angles. So this angle is 53, so is this one. This is 53 as well. And so now we're looking inside this triangle. And what do you know about triangles? You know that all their angles, all three angles together, is going to get you 180 degrees. So let's look for this angle here. Angle A. Let's call it angle A. Let's look for angle A. So what you know is that 60 plus 53 plus angle A is going to get you 180 degrees. Okay? Also, you add them together, you get 113 plus angle A is 180. And then you subtract 113 from both sides. And angle A is going to be 67. Okay? Then you know that this is a straight angle. So you would say 180 minus 67, and you should get 113. Okay? So, but here's the other thing. That's one way to do it. So this is like method one. Yeah, method one. Okay, but method two goes back to the remote exterior angles. If you know about remote exterior angles, you can look at this and know that X is a remote exterior angle. Okay? So the value of X is the value of the two interior angles. The remote interior angles of 60 and 53. So you know that X is going to equal 60 plus 53. And so you'll get 113 as well. Okay? So it's two different ways, but it's with geometry, if you know the rules, solving the problem is going to be really, really easy. And so that's what I know here, is I know these rules. So personally, I would have did method two first. If I had to solve this problem on a test or something like that, or some homework, I would have did method two. But if you don't know method two, then you do method one. So hopefully you know at least one of the methods to help you out. Okay, what is next? Similar triangles. So, two similar triangles are shown. It says, what is the measure of angle P? So, what do we know about similar triangles? So, anything with similar, similar means that they have, you have the same shape, but you have a different size. And that's what you're working with when you're working with similar. What is preserved? Angle measurements. I put angles. Angle measurements are preserved. And what do I mean by preserved? I mean that they stay the same. And angles are the same. Same. So it doesn't matter the size or the shape. As long as you keep the same basic shape, the angle measurements are going to stay the same. So with that being said, it says, what is the measure of angle P? So you have to look at the corresponding angles. We know that H and M are the same. They're both are right triangles. They're right angles, and they have the degree measurement of 90 degrees. So I can put 90 right here. They're in the same location, so they're corresponding angles. They correspond to one another. And then we also know that J and N are the same. So if you know that J and N are the same, you know that angle J is 26.8. So guess what? If that's true, then it's true for P and K. So if K is 63.2, so is P. So the measure of angle P is 63.2 degrees. And that's it. I know a lot of people don't like geometry, but I actually like it. I think it's easier than algebra. But that's just me. My personal preference. Okay, here's another question. Let's see, where am I? So, here's a question here. It says, which set of numbers form a right triangle? So, here, another rule you have to know. With this particular problem, I would use my Pythagorean theorem rule. So, let's write this down. Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared is equal to c squared. And this works with right triangles. Okay? So you have your basic right triangle. And you can call it, hold on. Usually label with capital letters. Angle A, angle B, angle C. This would be the right triangle. And then when you're labeling your sides, let me label them different so I can really get this right. Let me label this a little bit different. Okay, let's go back. So I'm going to label it A, B here, and C. And I'm going to do that on purpose because I want you to see how they get these, the A squared, B squared, C squared. When you're talking about this theorem here, you look, the angle here, A, you look at the opposite side of A, and you label that lowercase a. And then this is B, and the opposite side is here, you label that lowercase b. And then across from C is lowercase c, which is the hypotenuse, okay? Y'all remember this stuff? Hypotenuse. Okay, and these are your two sides. And I didn't mean to put the square, but yeah. So you got A, B, and C. So when you're looking at your answer choices here, that's how you should look at them, as A, B, and C. So let's analyze each answer choice and see which one of these is going to give me a true statement that A squared plus B squared is going to equal C squared. So if I go to answer choice A, we have 1 squared plus 2 squared is equal to 3 squared. So that's going to be 1 plus 4 is equal to 9. That's 5 equals 9. That is not a true statement, so we're not going to pick that. Let's go to B. So for B, we have 3.2 squared plus 7 squared is equal to 8 squared. So 3.2 squared is, let's just do the math. 3.2, 4, 6, placeholder, 6, 9. This is 4, 12, 10, 2 decimal places. So 10.24 plus 49 is equal to 64. Well, this is going to equal 59.24, and this is 64. Not a true statement. So when they are not true, they're not forming a right triangle. Okay, let's do another. Let's work on answer choice C. We have 3.6 squared plus 4.7 squared equals 5.2 squared. Well, I'm not going to work them out by hand. Let's see. I think I wrote this down somewhere. Okay, so this one is going to be 12.96 plus 22.09 is equal to 27.04. So when we add this together, we get 35.05 and then 27.04. That's not a true statement, so it can't be that. Now let's do answer choice D. We have 6 squared plus 8 squared is equal to 10 squared. So this is going to be 36 plus 64 is equal to 100. And 36, 64, 9, 10, that 100 equals 100. We got a winner chicken dinner. Sarah, you are so right. Your dad would be proud of me. I mean, I was in his math class, what, 7th grade? And I just remember him sitting in front of the class talking about 7th period. Yeah, your dad would be proud. Yes, he was my math teacher in middle school, Mr. Bernie. Love him so much. Okay, so that is it. Answer choice D is our answer. Yes, I can credit Mr. Bernie as one of my teachers who taught me well. He's actually a teacher who taught me algebra. No, it was, I think, a pre-algebra, 8th grade math, something like that. When I was ahead 1 grade, so he was the one who did it. So thank you, Sarah, for reminding me of that. Westwood Middle School, baby. Okay, here's another question. It says triangle ABC is a right triangle. The lengths of the legs are 60 centimeters and 80 centimeters. What is the length in centimeters of the hypotenuse? So I'm going to actually draw this picture just to give you an idea of what they're asking for. Again, we're going to use Pythagorean theorem because we are working with a right triangle. So I have my right triangle. And A, B, and C. Put my right angle here. And so they want to know that one leg is 60 centimeters and the other leg is 80 centimeters. And they want to know what is the hypotenuse. And so this would be my C, which is also known as the hypotenuse. So we're going to use Pythagorean theorem. Which is a squared plus b squared equals c squared. And so we have 80 squared plus 60 squared is equal to c squared. So this would be 6,400 plus 3,600 is equal to c squared. Together, I think that's going to get you, what is that? Hold on. 10. So we get 10,000 equals c squared. Now this, you got to take the square root of both sides. And so c is equal to 100, in this case, centimeters. Awesome. Okay, next question. So this one here says triangle ABC is a right triangle. The length of one leg is 80 centimeters. The length of the hypotenuse is 120 centimeters. What is the length in centimeters of the other leg? So hopefully when a student does this type of problem, they know the vocabulary. And that is very important, especially in geometry. Even though this is 8th grade math, you still got to know the vocabulary. And they would need to know this vocabulary again in when they get to geometry. ABC. One of the legs is 80 centimeters. The hypotenuse is 120. And you need to find the missing leg, and we'll call it A. So let's say A squared plus 80 squared is equal to 120 squared. So we'll work this out. You have A squared plus 6,400 is equal to 14,400. And so you can subtract this from both sides, 6,400. And you get A squared is equal to, what's that, 8,000? And so you got to take the square roots of both sides. And so A is going to equal, I need to open my calculator, y'all. Hold on for a sec. Make sure I got this number right. Okay. Oh, clear. 14,400 minus 6,400. And then you take the square root of 8,000 and you get a big old decimal. 89.44. We'll stop there in centimeters. And that would be the value of the missing side or the missing leg. Okay, I think I have just one more question and then I'm going to call it a night. Now, here's the thing. I have people who text me throughout the week sometimes and they ask me questions. And that's when I do them on the live. But I usually do them for that person on the same day that they text me. But then I'll come on Monday nights and I'll do it. So if you find yourself during the week where you need help with math, you can text me at the number 407-801-9255. I'll try to get back with you on the same day. But then you'll also see your problem during the live session. So that's what I did tonight earlier. Okay, so here's one more question. This question says 2 points are on the coordinate plane shown. It says, what is the distance between A, which is at -5 and 3, and B, which is at -3 and 5. Now, you can do this question 2 different ways. I think I'm only going to do one way because I just think it's the easiest way. You can use the Pythagorean theorem here. You can also use the distance formula. But I think in 8th grade, I don't think they teach them the distance formula. I think they don't learn the distance formula until they actually get to geometry. But in 8th grade, what you can do is teach the students how to make a right triangle given 2 points. So that's what I'm going to do here. So we'll connect A and B. And then if you notice, you can draw a line down and like this. And you have a right triangle. So if you look, one side is 2. The other side is 2. And you're left with basically C, which is the hypotenuse. So you just do the problem. You have 2 squared plus 2 squared is equal to C squared. When we find the value of C, that would be the distance between the 2 points A and B. So this is going to be 4 plus 4 is equal to C squared. That is 8 is equal to C squared. And the square root of 8 is, and that's what we're doing now, taking the square root. And so 8 is equal to 2.83 basically. And usually we just put the word units when they don't tell us if it's meters, you know, they don't give us units, we put the word units. So this would be your value of the distance between the 2 points. So that's all I have for tonight. If you have questions for me, you can text me throughout the week. My number is 407-801-9255. I'll be more than willing to help you. And so that's it for now. So ta ta for now. See you next Monday. Bye bye.